All right. So this is Tuesday, April 24th, data representation. So it says Jordan and Kaylee each conducted a survey on their school campus to determine the ages of students in the cafeteria during a lunch period. So it says write a statement that compares the spreads of the data. Well, another word for spread is range. So you got to find the range. Well, the range for Jordan is 4, and the range for Kaylee is 4, because you have to take your biggest number and your smallest number and subtract them. So you would say the spread or the range is the same for Jordan and Kaylee. So then we're going to describe the shapes of the data distribution for both groups. Well, the shapes would be most of the data for Kaylee's is around 14 and 15, while Jordan's data is between 12 and 14. If you need time to copy it down, you can always pause the video. Okay, which measure of the center is best used to describe each data distribution? Well, another word for center is median. And remember, the way you find the median is by cutting one off to the side from the other side. One from side, other side. Side, other side. And when you do that, you get down the center. So Jordan will be 13, and Kaylee will be 14. So you're going to say the center, or the median for Jordan's 13, while the center for Kaylee is 14. Again, you can always pause it if you need to write this down. Okay, number 4. It says Felix uses a graphing calculator to generate 2 different lists of numbers ranging from the 0 to 20. A number may appear more than once in a list. Each list contains 10 values. The resulting lists are summarized in a box plot below. Write a statement comparing the spreads of the distribution. So remember, spreads range. So you take your biggest minus your smallest. And when you do that, list 1 has a spread of 18, while list 2 is a spread of 17. And then 5 is talking about the center. Well, another word for center is median. So the median is right here. Whoops, a little off. And right here. So the median for list 1 is 9, while list 2 is 11. And before we actually go on, I want to do something real quick. I want to remind you of something about a box plot. So here we have is a box plot. And I want to remind you that the whisker is 1/4 of the data. One of the boxes is 1/4 of the data. The other box is 1/4 of the data. And the last whisker is also 1/4 of the data. It makes of 4 quarters. So this is 25%, 25%, 25%, 25%. So another thing is I want you to remember is this is your minimum and this is your maximum. This is also your first quartile or upper quartile. This is your second quartile or center. This is your third quartile or your upper quartile. And that means I got this one wrong. I'm not sure why I said upper. That's supposed to be your lower because it's your lowest one. Quartile. All right, so another thing we're going to talk about is skewed. Skewed right means all the data is to the left. So it means if you had a box plot, your box plot would look like something like this. The reason why this is considered skewed right is because of this right here. These are very, very tiny compared to the rest of the box. It means most of your data is right there. So just think opposite. So skewed left means right. So if you had a box plot skewed left, your data would look like this. You see how this is smaller than the other side. I would suggest writing this part down because you have a couple of questions over your homework about skewed. Okay, number 1 on the back. A survey is conducted at 2 junior high schools asking students about the number of sodas they consume each day. Based on the data shown in the graphs, which statement is true? So first off, we got to find our spread. Well, the spread for junior high A and B are both 10. So the data distributions would be the same. So the answer would be B. Okay, number 4, the centers of both of the data distributions for brand A and brand B are equivalent. The reason why they're equivalent to 12 is because when you find the center or the median for brand A, you get 12. When you find this median for brand B, you would land in between 11 and 13. So that'd be 12. So they're both the same. Okay. Again, this really doesn't require a lot of math. It just requires you to look at your data and make representations from it. So take your time, slow down, reread it, and disprove other answer choices if you get stuck. Okay, thank you guys.